Okay. So you can see my screen, right? So, and now we have to talk about types of functions. Okay. And yesterday we have discussed about different types of function arguments or function parameters. And today we will talk about different types of functions which we regularly use in our Python development. Okay. So one is built-in functions. Yesterday we had a quick idea about this built-in functions. So now we know what are built-in functions, how to use built-in functions, all that, because we also had discussed all these data structures or collections, and we covered so many built-in functions like length, sorted, or find all. There are many max min. There are many built-in functions. And even yesterday, we tried to understand some built-in packages or modules yesterday, like math module, sys module, something like that. Okay. Now, next thing is user defined. This is already discussed and we know about it. Already we have these videos, recorded videos in our YouTube channel as well. So if you are interested, you can give it a try. Just an FYI. Then today, the very important thing is we should talk about Lambda functions and the importance of Lambda functions and how we can use it. So let's understand about all this Lambda functions in detail. First thing, what is Lambda function? Or we can also call it as anonymous. Okay, anonymous function.
Sir,
So
built-in functions, map, filter, reduce, not explain it, sir.
no,
After
no,
this one,
we'll discuss that. Definitely, we come to that map, filter, and reduce after there are after completing the function topic. Okay, once we do all functions, then again I come back to this advanced built-in functions. Okay.
okay.
So first you get some idea about Lambda because we use Lambda functions even in map and filter and reduce functions, Tulsi. So before we jump to that topic, because one complete session we focus on map topic, filter topic, and reduce topic. Okay. So that they are very important. I definitely we are going to talk about them. No doubt about that. And people ask questions in interviews about all this. Okay. So
Okay, sir.
now so actually, we have so many things to cover apart from
Sir,
Lambda functions,
sir,
recursive functions. Yeah, yeah.
are you recording session?
Yes, yes.
Okay,
Uh,
okay.
you can see here. It's already in recording.
Yeah,
Hmm?
okay. Actually, logged in mobile, so
Oh, no problem, Krishna.
okay, fine, fine.
Okay, let's get into that. And we have something called inner functions, and there is a topic called decorators. I'll just give a quick idea. Later on, maybe if you think you can practice more examples, but these are important things. Sometimes people ask these questions in interviews. Definitely, people ask more about decorators as well, just to have a clear overall idea about everything about functions. We will cover these things first, Krishna. Once this is done, once we are cleared with functions, then we jump to this topic and then we go to next topic. Okay. So that's it. Let's go to the Lambda functions here. What is Lambda? These Lambda functions are also called as anonymous functions. Means simply speaking, function without any name. These functions don't have any name, and such functions exist not only in Python, even they are there in Java or C Sharp, and in C++. A similar kind is there. What we call them as inline functions. Something like Lambda, we have inline. So this kind of thing is there in different languages. Okay, but in Python, simply speaking, what is Lambda function means? These are anonymous functions or functions without any name, right? That is one thing. Second thing, generally, these functions are implemented in a single line. How many? Right? If you are using Lambda function means you are creating a very short function and that too in just a line, in a single line. This is one more important thing, right? Next one. So another, this is second thing. And another important point is we can pass lambda functions as a parameter to another function. Again, see, the another advantage is if you have lambda functions, LEM, right? We can pass these functions as parameter to another functions. You got it, right? Yeah. This is one more thing. Got it? So this is another important point about lambda. So we have had quick discussion, 3 points so far about lambda. It doesn't have a name. That is one thing. Second thing, just generally lambda functions, not generally, lambda functions are implemented in a single line. Got it? Second point. Third point, we can use lambda functions to pass as a parameter to another function. Got it, right? We can pass lambda functions as parameter to another function. We'll see those examples as well, right? Especially this map example, filter example, reduce examples, right? To this, we will see two approaches of working using a regular function and lambda function, and how simple lambda function is we see when we are working on these examples. Okay, fine. Next one. So this is a quick introduction to lambda functions. Next one, the syntax is simple, so simple. It has the keyword lambda, that is important. What is that? It has a keyword lambda, and then you can use parameter, one parameter or parameters. It's up to you. One or more parameters. Right. Okay. Colon. And then what is that you can add something like expression. That expression can be anything. You got it right, friends. So this is the simple idea. This is a simple syntax. If you want, you can just take one parameter or more parameters. This is a syntax of lambda function. And if you see, it doesn't have any line, any name here, like how we have for functions. Like def, we give some name and we add some parameters. But here, lambda don't have any name here. Then the question is, how do you call lambda functions? Then, if lambda don't have a name, how do you call it? If you want to call lambda, then you have to assign it to a variable, something like variable name equal to lambda. You can assign this whole lambda function to a function, to a variable, sorry. And this variable can be used as a function call. This can be used as a function call. Got it right, friends? So this is the quick idea. Maybe if you do a small example, you understand how simple lambda is and how useful lambda is. Let's do a quick simple example. Right? Open your PyCharm now, friends. So what do we do? As we are working, we use this functions package itself and create a small Python file. Just name it as lambda lambda underscore test. Right. These are very useful functions, friends. Lambda functions are really useful functions. Okay, we use a lot. Even today, I was working on some automation using some built-in framework of our organization. So that methods which I use is using internally lambda parameters. And that is the importance of lambda. Okay. Now let us start taking the example. So the first example is, let's just print a hello world with lambda. I'm just starting with a very basic example. Print hello world. How do you print? Simply LA? You can directly use print if you want. You can say lambda space. Okay. Colon. You can directly say print. You can simply here pass something in double quotes. Hello world. This is a simple example, very basic example. Even just to show you different varieties of lambda expressions. Okay. There are different ways we can declare lambda. This is very basic approach. Okay. Let's run this now quickly. And here, of course, we are getting, what is that we are getting here? We are getting a lambda function. So to avoid that, you can do one thing. You can assign it to some variable, some x equal to, then you can simply make this as a function call. In print, you can simply say x of something. You can see here, just we are not take this, it is not accepting any parameters. So not even you don't need to pass print statement, just call it That is enough. So you see here, assign this lambda expression to a variable and call that variable like a function. But of course, x is a variable, but as it is pointing to lambda function or lambda object, you can call this variable like a function. Okay, let's test it now. Okay, see, we are getting output here. Simple, right? So this is the quick idea. What is that? Even though lambda doesn't have a name, even though it is anonymous function, still what we can do, we can assign that lambda function to a variable and call that variable like a function call. Got it right, friends? So this x acts as a, this acts as a pointer to this or a reference to this lambda object because everything is object in Python. Okay, friends, this is a simple and very basic example of lambda. And even you can see you may have a parameter or you may have 0 or more parameters with a lambda function. Got it right? So that is the quick idea. Understood, right, friends? So I just share this code base with you. Okay, you can, if you want, you can give a quick test. This is a very basic example. Now I'm sharing in the chat box. All this in the chat box. What you can do. So insert. This is the very simple and basic example. I think I inserted, but I didn't send it. Just a minute. Let me send it. Yeah, now it should be. Next example. Another simple example is with lambda is, let us take one more simple example. I'll add here itself 3 or more scenarios. We'll quickly add it, understand about lambda. Just remember again, we'll come back to this topic. Okay, next one, adding or finding sum of two numbers. That we do with the lambda, finding sum of two numbers. We can apply that with lambda. How do you do that? Simple again. Sum of numbers equal to, okay, you can use lambda, you can apply lambda function. Then to find sum of two numbers, how many parameters are required? Two parameters. You can add two parameters, x comma y, and then logic. Simply you can say x plus y, that's all. You don't need to do anything. See, this is equivalent to creating a function, right? If it is a function, how would it be? I'm just showing you. If we expand it to a function, function look like this. Just showing you for better clarity. Okay, see here. If it is a function, sum, you can say sum of sum underscore two brackets x comma y. Like this, we create a simple function and just we say c equals some x plus, or otherwise we can simply say return x plus y. This will also work for us. Okay, we can create something like this. You got it right, friends? So this is a regular or a normal function. And same thing if you apply to, if you convert it to lambda, it's almost, you can see, except name thing, we use a keyword lambda. You can see it takes two parameters and we applied the logic. That's all, friends. You don't need to use any, you don't need to return anything here. No return keyword is needed for lambda. Another important point. What is that? No return keyword. We don't need a return keyword, simply speaking, is needed. That you can just write in whichever format you want, right? That grammar thing you can take care. So we don't, or no return keyword is needed here. So suppose even if you apply return, it won't accept. See here, I'm just giving you a few important details. Because by default, it is returning. Implicitly, it is returning. Again, explicitly adding return doesn't make sense. So better let's remove that. And you can see immediate error there. I added return here. Once if I add included return here, see the error. What is that? It is saying it is something out of function or something. So better remove that because returns statements are not accepted here in lambdas. Why? Because they are These values are implicitly written by Lambda. Okay, fine. Now you should get a clear idea because we have, what is that? We had a comparison here. We just implemented another regular function, how we can find sum of two numbers, and we are trying to compare both of that. And if you see Lambda, it is much more simplified, and we multiple lines of code we implement just in a line. And if you are familiar with comprehensions, this is easy to understand. We try to implement number of comprehensions like list comprehension, tuple, dictionary, all that. So if you say this is much more optimized, right? You can see it is much more refined compared to this one. Right now, I hope you understood this, friends. So you got it right, Lambda and then parameter list. How many ever you want, you can pass it. Depends on your logic, and then just find the implement the logic. That's all, friends. Now assign this whole Lambda function to some variable. Now what is that I should do? I have to make a call to this. What is so now I should call Lambda function. And how do I do that? If I should call Lambda function, then I should call Lambda through this variable. So now what I am doing, I'm calling Lambda through the reference variable of Lambda, this variable, and make it as a function call. And to this, right, Lambda is accepting what, or it is declared with two parameters. So Lambda have two parameters. Then while making a call to Lambda through this variable, you should pass two values, something like 10, 20. That is important, friends. Or if you want, you can read from keyboard. It's up to you. I'm taking time and making sure that going very slowly, because once you understand these basics, even if it is a little complex example, you can easily understand. So that's all, friends. But this time you have to either assign this to some variable, because Lambda just performs sum of two numbers and return the result. Now you are just making a call to Lambda by passing parameters. If it is returning value, either what you have to do, we have to assign that return result to some variable. That is very important, right? So I am using some value. You can use any variable. I am using a some value here. That's all. Now what you can do, print simply the sum of two numbers is, okay, or you can use X or Y, whatever you want. It's up to you, friends. Is and one flower bracer dot. If you want, you can take three flower bracers and print that input values as well, X and Y as well. It's up to you. 10 and 20. But I'm just using one placeholder just to display final result. Okay, and just printing some val here. Okay, so that's it, friends. This is the quick idea. Now what is that you should do? You have to run this code, and I'm removing this regular or normal function. Now I'm running this code. You can find two outputs, one from the first Lambda, basic Lambda, just prints hello world. Second, we get output as 30 here. See, that's all. Maybe there is a little typo, no problem. So this should be fine, friends. This is how we work with Lambdas. Got it right? One more example, right? This is second example, finding sum of two numbers. Next example is, I think, I just took some examples here. Adding fine, sorting Lambda. Let us take this data set. I want to sort, not sorting Lambda. I want to sort a tuple using Lambda. What I want to do, sort a tuple using Lambda. So what do we do for that? Simple. Let's another scenario. Sorting a data set using what, friends? Another use case using a Lambda function. Simple, right? Very simple. First, take the data set. Maybe I'll share this data set with you also, friends. Okay, I'm sharing the whole code with you. In that you have data set as well. Just copy it for testing purpose. Okay, let's Let me add the code snippet in the chart. Okay, take this. Please take this, friends. Okay, so we are sorting the data set here using Lambda function. What is that I should do? We have a data set. Simply go to the this one. Apply. What is that? Sorted. This is the variable I am assigning. Sorted data equal to. What is that I should do? First, I should use Lambda keyword followed by. And what do I need here? If I want to apply sorting. So one thing, sorry, we cannot directly apply this. We are doing sorting, right? So to do sorting, first thing we have to use a built-in function sorted. And this takes first parameter as what? First parameter as this one. Okay. Data dot. What you can do here. Okay. Let's pass this and see. Okay. Comma. Key equal to. What is that I can do? Lambda. Now you understand this quickly. So then sum t colon t of 1. So internally you are taking that data set and then on which key this sorting should happen. There are two keys, right? One is your value, another one is your this one. Sorry, one is the number here, and the other one is the which one is here. Other one is apple or the fruit name. So we are trying to sort it based on fruit names here. Let's see how it works. Okay. So I'm just passing this. Let's see if this is work, if this is going to work, or else we'll just check it out later. So we are done with this. This is how you do sorting. And to this, we are passing actual data. And to do this sorting, we are taking the help of Lambda here. See. So to this Lambda, what we are doing, we are just taking a parameter. And that parameter is something second argument of this data. And based on the second argument, we are trying to sort this data set. Okay. So implicitly sorted method will take care of doing that exchange, all that. Here we need to pass two things here. And there is one more thing if you want, you can pass if you want that output in descending order. We'll see that in the after running this. Okay. Let me run this. This is the simple idea how to sort data set using Lambda function. Right? We apply sorted function and Lambda alone cannot sort it. We are taking a help of Lambda here to do this sorting. And this alone cannot completely do sorting. Right? That's it, friends. Let's run. Let's print first of course, to get to see the output. Print this sorted data and then run this, friends. And now you can see here banana got shifted here, right? You can see apple is first and then banana is next, orange is later. And it's sorting according to the alphabets here. You can see here A, B, and then O. Sorting happened or not? Yeah. Maybe you can ask me, Manoram, I want it in descending order, not in ascending order. This is ascending sort. Maybe you can just add a point here. What is that? This is ascending sort. And remembering these are important, friends. This ascending descending matters when you are working in a project. Sometimes we need to do which sort? We need to do ascending sort. Sometimes we need to descending sort. Remember, because I keep working on these scenarios, so I'm just trying to give you that FYI for your information. Okay. Next after this. So I want to sort it in descending order. If we want to sort in descending order, simple. So you can just say AAC. Naming is also important. And here, just simply you have to add one parameter if you want to sort it in descending order. What is that parameter? Simply you have to use a parameter reverse or a flag reverse and set it to true. When you say reverse true, then all your data set, whatever data set it might be, friends, it might be a tuple of list of apple or sorry, list of fruit tuples, or it might be list of books tuples or whatever it is. If you want sorting in descending order with this sorted method, you can use this reverse parameter. Okay. And set it to true. Okay. And finally, you just name this as DSC underscore sorted data and then pass it to the print statement here. Okay. And you can write here, what is that? Descending sort. So DSC E and D descending. Somewhere if you have typo, just ignore it, nothing happens. Okay. This is the simple idea, friends, how to sort a data set using Lambda function. See here, friends. Let's run this now. Now you see this got sorted in descending order. When we apply that reverse parameter with that sorted method, this sorted data got sorted in descending order. See, orange first, banana next, and apple later. And just check on this fruit values. Don't check on the your integer values. Okay. So this is how we can apply lambdas wherever we want. And lambdas are simple and sweet to add or insert in your code snippets or code blocks. Even while working with comprehensions, definitely lambdas are very useful, friends. You got it, right? Suppose we are iterating another scenario, right? Finding squares of numbers. This also gives you an idea. How can we insert this lambdas into code blocks? How simple it is to just insert it somewhere in your code. You got it, right? Finding sum of squares of numbers from 1 to 10. So what we are doing now, let's take a comprehension. Let's apply this whole process in just one line, that too using a list or tuple comprehension. Okay. So you just pass a number, you should get a square. The easiest way is some squares equal to what you can do, start a comprehension, list comprehension. And then here we'll come to lambda part later. First apply iterator for I in a range of 1 comma 11. This iterates from 1 to 10. Okay. A range gives you how many numbers? 10 numbers, 1 to 10. Right. So 11 is excluded. It won't consider 11 here. Okay. This is fine. Now on top of this, what is that I should do? LAMBDA. I have to simply use some x colon x into x. That's all. Right. You can see here. So what is that I am doing? I'm iterating a range of numbers from 1 to 10. This range function provides a range of numbers. It generates a numbers from within a given range here. And this is also a collection. So that's why I'm passing it directly to the iterator for iterator. And this iterates for 10 times. And that I value is passed to lambda, which is nothing but copied to x. Every time I loop iterates, one value is passed to x. And after that, it performs a square and that is returned. And those returned values are actually captured internally by that list comprehension. Okay, let's print squares and see what would be the output here. This is a see how simple this is. Got it, right? Right. I'm just showing you one simple scenario of lambda here. Likewise, you can add how many ever you want, friends. It's up to you. Okay, let us test this quickly. Let us run this and see how this works here. Right click and run it. Oh, it is generating a pure lambda functions here. Okay. No problem. Let me quickly check it. Using lambda in Python. Okay, let's take this. Because generally lambda implicitly written value, right? This is generalized approach. With lambda map, all this is fine. I don't want map. Sorry. I think I have to pull it to the bottom. These are all fine for us. Okay. Straight examples we can try. Okay. Otherwise, let us take chart GPT. GPT. Finding squares of numbers using lambda in list comprehension. Let's see. So it is adding another parameter. See here, we almost we are near to the this problem. I mean to the answer. I think it is adding extra so that acts as a return, I believe. So what I do is just add it and see how it works. So we have to apply simple bracket. After that bracket, one more this thing. That's all. Let's run this now and test it. This is not at all working. Oh, it is passing this one list. Of course, in any way it should work, right? If it is X or anything. This is perfectly passed. Okay. Yeah, that. Even if you use that list as well, I don't think there is big difference between range or list. X into X is fine. We are saying. So generally, when you have error like that, just copy it from this one. It's type error because I want to know why it's missing that when Chat GPT gives. You can see here, right? It is saying lambda function syntax is misused. When I asked it ChatGPT, then it is correcting now. See, this is a fly on ChatGPT. You got it right. So now you should understand about not everything that is given by ChatGPT is a working solution, right? Anyhow, we are not testing ChatGPT here. So then there is another way of doing this using map function. Anyhow, we are not jumping to map now. If it is, then simple thing is you do one thing, remove this per list comprehension. You don't exactly need lambda. You can directly apply this. It gives you the output. That's all. Okay. X into X not working. Why? Nesting generally is a multiplication operator. I didn't understand why it's failing. Right? Squares. Are you getting the output of squares? Okay. Might be it should be because of I into I. It will work now, friends. See, working. Maybe if it is lambda also, let me try the lambda. I colon I into I. This I think this is a parameter we can name as we like. It's not the issue with lambda, but issue with the syntax itself, not just lambda, friends. Anyhow, it's fine. We are getting output again. All these values you have to call. You have to make a convert it to a function call again. You got it right. So what is that you should do? You should iterate that list and then convert it into a function call, something like this. If you want some output on this, then what is that you should do? Again, you should iterate it for some square. Just type square in squares. Okay, colon. What is that you should do? Print off. You have to say square and make a function call. Convert that call into a function call like this, and that too, should we pass any value? Let's test it, friends. Are you following or am I confusing you? Just giving you a quick idea how to use Lambda, but this is becoming a little complex here. So we can avoid this scenario. As anyhow, we started discussing this. I'm just trying to bring solution from there itself, friends. That's all. Okay. So if you want to go with this approach, you can go with it. But only thing is, when you have to iterate it and make sure that you are converting this each time you are calling it, convert it as a function call. Okay, let's see if this works directly, and it's expecting value here. So this doesn't make sense, friends. Finally, this conclusion is avoid this. Just use direct approach. Don't apply Lambda here. That doesn't fit into this scenario. So I misuse the scenario. Okay, my scenario is not a right scenario to include Lambda. Got it, friends? Because it is going too far. The purpose of using Lambda itself is to simplify things. And again, if we are again making it a very complex situation, then it's altogether we can avoid it. Okay, maybe just print it. Okay, this squares. Okay, this is a list comprehension. We already know about it. These are very basic, simple examples. That's all about this one, friends. Lambdas. Maybe if you want in future, we will discuss again one more time about Lambda. With what? With these scenarios. What are those scenarios with this built-in functions like map, filter, and reduce? Let me finish remaining things today. Next scenario. This is all about the basic understanding about Lambda. I'm sharing all this code base with you. The last one is just a list comprehension. It is not Lambda. We don't have anything associated with Lambda here. Okay. Right. Next one. Let me share the code before I jump to the recursive functions. Let me add something here. Where is it? Sorry. Okay, let me cancel it. This is not in the right format. Something went wrong here. Okay. The problem is I'm not seeing this. I got it. Let me put this at left side. Yeah, adding it. Now you can take all this code base, friends, and you can start working with that. Okay. And then sending it. Please take it and test it and see how it is working for you. Only the simple tip for you is if you think it is useful, give a try. Don't copy and paste, and try to type and see, understand and implement, see how it is coming. So that gives you more better understanding, a deeper understanding of your topic. Okay. So we are done with this, friends, with this Lambda. I mean, I'm done in sense, no, we just got a clear idea about the fundamental, this thing of Lambda. We will use it again and again in many scenarios, which we see in future. Okay. Now, next topic is recursive functions. What is a recursive function? People use a lot of recursions when we work with exclusively data structures. Okay, so and in development, sometimes in some scenarios you might need recursion, you might apply it. Okay, so let's take another. You can close this file, friends. Let's go to the next topic. So recursive functions. You can take some factorial or something, and then you can give a try on that. Okay. Underscore functions. I'll just show you two different scenarios. One is doing factorial with recursion. Second one is doing addition of two numbers with recursion. And recursion is applied a lot in different data structure algorithms, friends. Okay. So where there is divide and conquer algorithms, in such places, people apply a lot of recursion. But we don't need at that level here because we are not into the data structures. right? So first thing, what is recursion? A quick idea. Recursion means a function calling by itself. Generally, what is that here? We call a function from outside a function. So recursive functions means, simply speaking, a function calling by itself, calling itself, otherwise, simply speaking, itself. Then you might ask me, anyhow, every function is called by itself only, right, Manoram? Yeah, you call it from outside. Like if you take this example, right, any function, because we already did so many functions here, I can close. I don't need these many windows. Okay. So you take this function. So this is also a function, and this is calling by itself with some name of that function itself. But we are calling this function, you can see here, run_db, we are calling from outside. Suppose you take this run_db, you put here itself, right, inside that function, right? What is this happening? This function, whatever that is there, right, that is being called within that function itself. And this approach and this situation is called recursion. Like we talking to ourselves. Generally, sometimes we self-talk, right? So something like that. That self-talk we do with ourselves is kind of recursion in programming. It's self-calling, right? So so that is what we call a function calling by itself. Okay, calling, you can say simply by itself, is called recursion. And generally, what is that? How do you implement recursion? Let us take a small example and get a quick idea. So we use one is factorial. Best example to understand recursion and easy thing to understand is apply factorial. Right. Second one is same thing on the same scenario on the same lines. We can apply sum of first n numbers. Sum of first n numbers. Factorial and sum of first n numbers have a kind of similarity, except that operator change the behavior functionality is almost similar. Okay, so factorial means, if you want to find some 5 factorial, suppose you have some value n, right? You have a simple test case for this. Okay, what is that test case? You have a value n and sorry, you have a value n and you have a value assign some 5 to that. Now you have to find factorial of 5. Right? How do you find 5 factorial? We know very well. 5 factorial means something like 5 into 4 into 3 into 2 into 1. This is what we know. We already know all this, right? So this is factorial. This is fine. How do you apply this? We can do this. We can solve this problem in 2 ways. With a non-recursive function and with a recursive function. We can do it in 2 ways. In both ways. If it is a non-recursive function, how do you do that? It's simple, right? We can apply both. But we choose recursion here. Okay, where is that method here? We can close this, friends. So now factorial of a number. I am directly jumping into that. Or do you want me to show how to do factorial using non-recursive function? Same thing, how to apply with recursive function. Simple. Anything is fine. You can show both. You can get a quick idea about both here. So if it is a non-recursive function, def some factorial, and you take that value n here to find factorial. And the logic is simple. Some fact equal to set to 1. And then what you have to do now, you have to take a loop for, which loop shall we take? Yeah, we can take for loop for I in a range of, okay, n comma, you have to iterate till 1. So put 0 comma minus 1. Colon. This is non-recursive function. I am just implementing in non-recursive so that you get a clear difference between recursion and non-recursion. And we are very much using all these functions so far. We are using our non-recursive functions. Most of the time we use non-recursive even in development. But in peculiar cases, we might use recursion as well. It's up to us. Okay, this is a non-recursive function to find factorial. Factorial means what? You should start with that 5, 5 into 4 into 3 into 2 into 1. That's what we are doing. You can see we use range function to generate numbers from 5 to 1. And every time it iterates, what is that? You should do fact equal to fact into that I. This gives simply what is that factorial of a number. Okay, why this error here? Are we missing it? Let me put a cursor here. Unresolved reference. And okay, that's fine. That will be removed anyhow. And once we pass value, return fact. Once after you find factor, just return it. That's all, friends. So this is how you can find factorial using non-recursive. Now, what is that you should do? So here we are testing function, means calling it. How do you test it? Test case one. We'll just send 2 or 3 values. So apply factorial, call factorial here. And to this pass what? Pass your value, something like 5. In first case, we are passing 5 and seeing what that is going to return here. Okay, let's print it directly. No need to assign to any variable and do all that. Okay, just print it. And then run this now. I think why this is showing error. This should work. I don't think we can put in no problem with that. df factorial, that is fine. Okay, let's run and see if it really have issue. Okay. We are missing operator in operator here. I'm just wondering what is missing here. Okay, now we should be fine. This is not issue with operate parameter, issue with the syntax of iterator here. Okay, let's run this. This will work pretty well. See here, we got 120. Maybe if you want, you can create one more test case to test this non-recursive function. Just pass some 10. You get factorial of 10 with this non-recursion. Right click, run this. Same thing, we try to work with recursion now. Now I am adding another function, recursive function. I think I used it a long time back, but it's okay, no problem. Def, same thing, copy everything. Okay. So you can copy and paste the same code. Just a change, a simple change is you just need to add an if else here. Remove this if n equal to 0 or n equal to 1. Then you simply say return 1. Okay. Once n becomes 0, you should just return 1. That's all. And that will stop the execution flow. And then now, what is it here? What is the logic? You have to say some fact equal to. You don't need to reinitialize anything in the beginning. You don't need to do any pre-initialization. Directly use fact here and use that n into. Then you have to apply. You have to call the function like this, factorial of n minus 1. So this is the logic you should apply for recursive function. And you can see every time loop iterates, what is happening? First n is some 5, then 5 into factorial of 4. Again, it will call the same function. That 4 is passed to n, 5 get replaced with 4. And here, from here itself, you are calling the same function. Its own function. Again, what it will do? Again, it calls this function is copied. This copy of, sorry friends. Sorry. This copy of function is internally one more copy is created. If I show in stack frames, it will be wonderful actually. But anyhow, I'm not getting into that to do this thing. But how would it be means? So now for first time, what happens is it would be like this. I'm giving a quick tracing 5 into factorial of 4. This is what happens. So, and again after that, what happens? Now, when you say factorial of 4, what happens now? This 4 is again implicitly passed to this n. 5 get replaced with 4. Again, this whole code gets executed. Now what happens now? It would be 5 into factorial of 4 means again n into factorial of n minus 1. This logic gets substituted. Means 4 into factorial of 4 minus 1, that is 3. You can see here. This continues till when it continues till 5 into 4 into 3 into 2 into finally once it becomes factorial of 1, it won't continue the process now. Then this 1 is written and it will stop there. And if you don't apply this condition, your program will be moved to infinite loop. If you just remove this and just try to find factorial, program just simply moves to infinite loop because this always n just gets minus with 1, then automatically 1 becomes 0, 0 become minus 1, minus 1 becomes something, all that. Okay. So to avoid all that, what is that you should do? Just once if n is 1, just return 1. That is enough. Let's try to test this. Now, what is that you should do? You can have this tracing in the code itself. I'm just adding there in comments. Let it be there. Now call this. For first time, you have to call it from outside. Again, if I am saying a function calling by itself means any function doesn't call by itself in the first instance. For first time, you should call from outside, and from there onwards, it just do it from inside. You got it right, friends. This is recursive function, factorial of. You can create few test cases here. Test case 1 with recursion. Okay, and you can pass some file here. Right now, just pass directly this to the print. Right, and then what you can do, test it now. So there is a small none type of. Okay, otherwise when n0 return 1, let it be like that. Okay, this is fine. Which is none type. Okay, you know why error? Because I didn't return the result here, friends. See here. We are passing this function call to the print statement. But if we are passing it, it should return that value. None, it has written none. Let's test it now. Return fact from here. Okay. So let's run it now. Now you can see here 120. You are getting a 120 here, right? See. Got it, friends. You got 120 for 2 times. First time from non-recursive function, second time from recursive function. Understood? So this is the idea, friends. And this is some factorial of 10 here. If you want, you can take multiple test cases. Are you able to get expected result here? Maybe because when n is 0, just return 1. Maybe is it because of 1? Let me retest it. It should, yeah. I think returning only the issue, friends, nothing more than that. Even you can stop that when n is 1. You don't need to go to 0 and then return it. Okay. So this is the idea, friends. This is the idea about implementing a recursive function. You can apply this. This condition is important. Suppose if I remove it and test it. Now you see what happened. Recursion error. See, maximum recursion depth exceeded. Why? Because it keep on calling recursively, and that recursive goes into the infinite loop. At some stage, it leads to stack overflow error. Implicitly, it runs into a situation called stack overflow. Right? Because functions gets executed from a memory area called as stack. Okay, if you are interested, I can again show you all that as well. Okay, but it's okay. For now, that is fine. So this is the idea, friends. I'm sharing this code base with you. Idea about how to work with recursive function and non-recursive function. And also if you want to see the performance analysis, if you want to check performance analysis, just take time thing, just apply start time of this code and end time of this code and see how much time it is running. Similarly, say apply same thing for recursive and see which is giving best performance. And if you want me to show, I can show you also quickly right there. So that is another important thing. Always checking a performance analysis also gives you a better deeper understanding of concepts. Okay. So I'm sharing this code base with you, friends. Not like this, sorry. Code snippet, insert, insert. Okay, this should be fine, friends. Shall I quickly do that performance check here? Let's do that. Just a minute after. I don't need much time. So, but we just need a timer in the beginning and ending of two functions. Each of this one. So let us just take that quick code because we need to search in our code base again. How to check time of execution of a code. And today we found out with practical examples, ChatGPT is not 100% reliable. Just keep in mind, friends, unless you know what you are doing, because this one is it just gave something like this. When we checked and see that, okay, see someone unknown people, if you just try it, there are flaws with ChatGPT. I see this now. You can use time module. See here, just take this. I'll just share this both to you. Just import time. We just need this start time and end time, friends. That's all. Nothing more than that. And then you have to do this abstraction and print it. That's all. We are done. So this anyhow, you don't for this you don't need to break your hand. I mean break our head. Okay. So what do you do? First import it. That is first thing. Okay, import time. Just showing you quickly because this is also very important for you when you are working in any record start time. You can copy this directly like this. Maybe you don't need to put everything inside that this thing because if you just put this here, that is enough. You function call within this start and end, that is enough. That gives you total time of execution. Just only add one use case because with recursion we just added one case. So to get accurate performance and after first one, I just stopped recording time. And finally, simple scenario is what that start time minus end time that gives you, or end here it is in reverse, end time minus start time gives you that performance of that. Okay, we are done here and just print that. Print off. I'm directly printing it now, not taking anything like execution time one. So maybe just add for without confusion, non-recursive. Okay, for this, how much time it is taking. And similarly, same thing, friends. Just copy this record statement. Now you don't need to go to ChatGPT. The only thing is you should know. So this is what we can do. This is how we get performance. That idea is important. Okay. Now finally just put that here. Start time. Second time record and time again. Okay. And then finally copy this compute execution time. And here put comma, friends. Just put comma or placeholder. Anything should be fine. We can use print in different ways. And finally, recursive way. This is what recursive, or otherwise just remove that. Okay, I didn't see that there. Okay. So that's all, friends. You can just if you want to have a different, you can use say repeat same variable because we are printing it then and there itself. So no issues, but still not to confuse, take that as execution time one, this as execution time two. And here also just add that. So now we can quickly check performance now. And let us pass little bigger values. Factorial of 100 you pass, 1,000 you pass, so that it gives better this thing. And here also pass the same here. Even here also just pass factorial of 1,000. Both in recursive and non-recursive, we are testing for these two scenarios. Factorial of 1,000. Let's test it now and see which has better performance. Somewhere it is having maximum. Okay. We corrected it, right? We kept it as is. So, okay. Maximum recursion depth exceeded. Let's run it again. This should work actually. We are code wise, we don't have issue. Factorial is fine, returning is fine, everything is fine. Why this is throwing it now? We corrected it, right? Yeah. Oh, see here. Okay. Do one thing, just make it a simple value. Because of this, it is struggling. Put 100 and see factorial of 100 with a non-recursive approach. So this is the value we are getting. See this. With the recursion of 1000, you can't even expect how
Hello friends, Sar is there.
sorry, there was some network glitch. Let's, uh, okay, we will continue this tomorrow. Okay. So had some network issue. Let's,
Okay, sir. Okay, sir. Good night, sir.
yeah, yeah. Thank you.
Thank you, sir.